Next, we got some work to do with this guy. Okay, now, when you're finding the area between two curves, we have to subtract those areas, because you find the area underneath one curve, then you find the area underneath the other curve, and then you subtract them. There is a shortcut. We could do the shortcut, but I'll state the shortcut at the end. So let's just do it all. So we got the integral from 1 to 4 of f. So f is x squared minus 4x plus 1. Let's see. If I do the antiderivative of that, I get 1 over 3 x to the third minus 2x to the second plus 1x. And then I'm going to plug in 4 and 1. So first I plug in 4, I get 64 times 1/3 minus 16 times 2, which is 32, and then I get 4. Parentheses, minus, now I got to plug in 1. I get 1/3, and then minus 2 plus 1. Now I got to simplify. So, let's see, can I divide 64 by 3? The answer is no, so I'm just going to write 64 over 3. I can combine these two to be minus 28. Over here, we have nasty stuff happening. We have 1/3, and then we have minus 1. Okay, now we have fractions. These are common denominators so far, so I'm going to leave them. I'm hoping that I won't have to change any denominators here. So if I add the opposite, I get 63 over 3, and I get 27. 63 is divisible by 3, so now we get 21 minus 27. I get negative 6. That's the area underneath the curve for f. Now we got to do the same thing for g. Let's do g over here. 1 to 4. Now g is 3x minus 5 dx. The antiderivative of that is 3 over 2 x to the second power minus 5x. Then I'm going to plug in 4, then 1. When I plug in 4, I get 16 times 3 over 2 minus 20. And then I plug in 1, I get 3 over 2 minus 5. Don't forget your parentheses. The 2 cancel out with the 16. It becomes 8. 3 times 8 is 24. I have to subtract 20. I get 4. On the other side, oh man, more fractions. I'm just going to add the opposite. So 3 over 2 plus 5. And when I add that, see, it'll be minus 3 over 2 plus 5. So 5 and 4 is 9. So now I have negative 3 over 2 plus 9. And if I make that to have common denominators, this becomes an 18. So I get a 15 over 2. Yuck. All right, so how do I find the area between these two curves? Do you guys remember what you're supposed to do with the areas? Subtract them. Interesting. Okay, so let's do that. Let's subtract these two. So we have, I don't know, to subtract what from what. But anyways, let's just go 15 over 2 minus negative 6. What do we get? Okay, so that's going to become a positive 6. This becomes, I can write it as a mixed number to be 7 1/2. And that means I get 15 1/2. Or I can say that is, do they have mixed numbers or improper? Oh, they have improper. So 2 times 15 is 30. And then I add the 1, so I get 31 over 2. Do you guys see that answer anywhere? I don't see it. I'm right. I just added the 6 and the 7 wrong. I had 13. And then what's 2 times 13? That's 26. Plus 1 is 27 over 2. I had a 15 here, and it was supposed to be 13. I added wrong. It's 27 over 2. All right, so that's one way to do it. You can find the area underneath each curve, then subtract it. Now, if I went it the other way, what would have happened? Let's see. I did 15 over 2 minus negative 6. If you did it the other way, you would have gotten, see, negative 6 minus 15 over 2. You find common denominators. Well, that's how I'm going to do it this time. So that we have a negative 12. Now, if I add those together, I have negative 12 and negative 15, which would be negative 27 over 2. But it's an area between two curves, so it's not going to be a negative. So we could just change it to positive and say, oh, the answer is 27/2. But now for the shortcut. How can we shortcut this? I don't know if this is much of a shortcut, but it would be for some problems. So we're trying to find the area between 1 and 4, and what you would do is you would know, hopefully, which one is above the other. Now remember, if you don't do it right, like let's say what we're supposed to do is G or F minus G. If you get a negative answer, you just make it positive. Okay, that just means you should have went G minus F. So it doesn't matter which one you subtract. So I have 1 over 4, or 1 to 4, and I'm going to say x to the second power minus 4x plus 1. And then I'm going to subtract from that 3x minus 5 dx. And so you would simplify this first, then do your antiderivative, then plug in all this stuff, and you don't have to do it twice. So we did it twice. We found the area of each, then subtracted, or you can subtract the functions inside the integral and then integrate.